Part 4 we re-up to the part of the story where I was off working in mission, which means all I can give you are the first and second hand stories that I've heard over the years. So I guess that makes them second and third hand to you. This would be a great time to watch the Channel 9 documentary for more authoritative information. In the last part, one wrote a little bit about what was happening in the VCI. Edit and continue for C programmers. Pretty amazing stuff. At about this time the internet happened. I mentioned it like it in passing. But, even looking at the phenomenon super narrowly, just from the perspective of how it affected our programming tools, it had some pretty big effects. Of course, probably the most major one was the creation of visual interdef to help people create great web applications. You know that Shell is going to be central to the story in a way nobody expected at the time. Okay, maybe the vid guys expected it. But nobody else. But also script and dynamic languages made a huge resurgence. Perl, Python. Remember websites in Perl? And of course, script, at first as a client-side language in the browser, but then more generally, and its twin in our world, VBScript. But for the web server needs and the browser needs, we might not have driven these languages within Microsoft as hard as we did. They helped our tools grow up in unexpected ways, like for instance, I think in VC5 you could finally call the editor grown up. It had been originally fairly underpowered as programmer as editors go. But in VC5 full macro support was added, not just little recordings using the VBScript engine. It still needed polish, but you could now no longer argue that it was lacking in raw potential/power. Like other MS applications, the macro language encompassed not just the editor, but virtually all aspects of the product. I remember making a command line debugger interface in an editor window with macros as an example for a friend. Speaking of basic, during all this time, our friends in VB weren't exactly idle either. In the VB5 IntelliSense makes its appearance. Can you imagine programming without IntelliSense? Well, I guess you probably all can, because many of you did without it in the past, but certainly a good amount of cursing happens in my office when I find myself without it. It isn't just that it saves you typing. It fundamentally changes the way you work. For many applications, IntelliSense makes API documentation obsolete, because it used to be that the one use for that stuff was to get method signatures. It is easily the one way people get help, blowing away the F1 key for usage. But it is more important than that. It goes as far as freeing you to use better naming techniques, especially in frameworks. Maybe Dennis Ritchie would not have left off the E in Crete if he'd had IntelliSense. And what about what it did for Office? The Visual Basic for Applications engine got IntelliSense too, and that meant Office programmers got much easier automation scripting. At any rate, IntelliSense was a total game changer and was soon in the entire Visual Suite. And by soon I mean what you might call Visual Studio 6.0. By an amazing coincidence, the language version numbers had synchronized or been forced to synchronize VJ and VID. Now VS6, and more importantly its parts, VB6 and VC6, are widely considered to be the best we ever made. Not universally, but certainly there are factions that think we should have stopped right there, or stayed on that track. I think this is true because they represent the last of that evolutionary line, for both languages. The idea that would become Visual Studio became available in its first incarnation at that time, as I have alluded to in the past, and it was Visual Interdef. In some ways, from a consolidation perspective, it looked like we had taken a step backwards. There were now 4 major shells rather than 3. The respective teams polished their products to a bright shine, and IntelliSense bloomed like daisies across the suite. For those of you that just lost me on shell count, I went to 4 with the addition of the VID shell used by VJ, at VB and VC, and that makes 3. What is this 4th shell you speak of, Rico? The problem is that in this entire history I've been completely silent on another suite member, Visual Fox Pro, which also had its own shell. Now there is a reason for this, and that is that I know painfully little about that product. Other than when I did a study of database technologies for Sidewalk in 1995, I was stunned by how many advanced features were already in the Fox Pro product. Who remembers Rushmore? I remember getting some pretty slick demos. Little known fact, it was the Fox Pro team that taught me the basics of database programming. Thank you, you know who you are. But, with apologies, I must go on, paying only very little homage to that shell. It would be great if someone else posted a My History that included more Fox Pro stuff. Or any other My Histories for that matter. I feel like I should mention Office a little bit more at this point. I've hardly mentioned Office, but it is important to note that Office, and the needs of Office programmability, were often key forces in language and tools design, to say nothing of the needs of the Office programmers themselves, which frequently pushed our tools to the breaking point. Probably more than any other single force, it was Office that was driving BASIC. From as early on as the embedded BASIC, which then went on to PAR VB, and then later VB, Office was a huge influence. I think specifically it was Office that drove how application automation had to work, and that in turn drove all automation generally, and that in turn drove BASIC. Those of you who have ever had to program with variants a lot can probably thank or curse this dependency cycle. One other big thing to mention, and then I'll wrap up for this installment. Another notable change in this time period was the maturation of the data access layers. I think this, too, was partially internet needs driven, but also I think the technologies were just ripe. OLED was born during these years, and with it the basic access mechanism. These things seem pretty mundane on the surface, but they offered much richer data access than ever before and inspired the first of increasingly popular and powerful data-grid mechanisms for both display and editing of data. When compared to the clumsy DDX/DDV type things we had been doing, it was a breath of fresh air for data programming and forms over data. All of this would go on to influence many different types of designers in data management services, but I think the spark for that was here, in say 1997. Visual Studio 6.0. Synchronized across the versions and starting to show some distant signs of consolidation between its various parts appeared in 1998. It was a great release, as I wrote above. It is still the favorite release of many. After that, the developer division went dark for about 4 years. They were working on what would become Visual Studio Net. Part 5. The years 1998 to 2002 were very busy ones in the developer division. I've previously written about Dolphin, and I tried to give a sense of exactly how much changed during the Dolphin release and the sheer volume of work it required, but I think this period dwarfs that one in a number of ways. Visual C 2.0 Dolphin was, by definition, just a C product. Putting aside the fact that it was designed to allow extensions for multiple languages, the scope of the system was limited to only one part of the developer division. In contrast, Visual Studio Net, which spans the 4 years we were talking about, and maybe a little more if you count the foundational parts that were already in VS6, was an effort that required the engagement of the entire division. Arguably it was the first time we ever attempted such a thing in the developer space. Just thinking about it from the perspective of the number of people involved is telling. VC2 was the work of 100-ish people. VS.NET required more like 20 times that, for more than twice as long. What kinds of things happened? Well, for starters, the entire managed stack of what we call the .NET framework had to be invented. Not completely from scratch, but pretty close. That is not just the runtime and the framework, but also all the supporting file structures for executable files, and inspectors for the same, a world-class garbage collector, in 2 flavors, several variations of JIT compilers, as well as precompiled and several new major language compilers, C, VB, .NET, and Managed C. A complete partial trust model allowing for hosts that want a sandbox solution. Debugging and profiling a piece for these components used heterogeneously? Bringing us back to the world of soft mode debugging, the runtime-rich interrupt choices for both direct calls and into and out of the framework, as well as sorted serialization and object remoting strategies, the entire ASP.NET stack for ICE new application models. WinForms and Forms for this environment, including a flagship design experience for both of these solutions that contain projects of all these types in arbitrary combinations, and that would handle of these new experiences, in addition to allowing unification of every major feature of all the other IDEs put together in with an extension model that would allow third parties to do their own languages/environments, just like ours. Lots more that I don't even have room for. It is quite an eye-opening experience to consider that all of these things were required to succeed, and you can sort of understand why it took so long. Some of the things on that list really can't be started until others of them are substantially done, but of course the more complex later projects are likely to highlight problems in the earlier stages. With so many people involved, just the communication overhead could be daunting, and the tasks above are hardly easy in the first place. Well, I'd like this to not read quite so much like a marketing bullet list, so allow me to recall a few stories about all this from my own perspective? Remember, I was still in mission here when I first heard about the next version of COM, which became the .NET framework. It was in the context of a pitch from the developer division to my mission group asking that maybe we should consider moving some properties to ASP.NET to give feedback. There was a lot of information to disseminate and many things were still preliminary, but I remember that there was one thing that I fundamentally did not get about the whole thing. It was because they were still calling it COM at that time, and I had assumed that they were trying to come up with a new COM framework that was backwards compatible with the old COM stuff like what we used in the DTC. When they told me that they were trying to do a compacting memory scheme in that world, I thought they were completely nuts. At minimum, you'd have to have proxy objects for everything so that you could move the real objects without anybody knowing. We were maybe 45 minutes into the meeting before I realized the magnitude of what they were proposing? They wanted an entirely new object model with an entirely different memory management strategy in all new languages. Wow. Just wow. The next demo hit close to home. It was a managed client for a web service. They just pointed the tool at a web service and instantly had IntelliSense over a bit using VB.NET. It had some rough spots, but definitely another wow. The next was a quick demo where they imported a COM component, the kind we used on our web pages for ad delivery and so forth, and then started calling that with IntelliSense support suite as you please, using nothing but the component STLB. I was so excited I got myself an early drop of the thing and started writing benchmarks. I wrote applications that did the kind of string manipulations that our websites usually did and sent them feedback based on my results. A lot of them made a difference. I had a sabbatical coming up, and I ended up spending most of my 6 weeks reading the base documentation for what they had built, partly to provide feedback, but even more because I thought it was going to be really important to learn it. It would turn into my next job 2 years later. What about some of those other items on the list? There is some pretty meaty stuff there. I'd like to pick off a few and talk about them a little bit, and I am so fond of debuggers. Let us start there. It turns out that debugging managed code can be pretty tricky. I alluded to the fact that it has a soft mode debugger like VC1. I say this because it has the key property of soft mode debuggers, which is that the debug isn't really stopped when you stop it. Both the VC1 debugger and the .NET Managed debugger share this, but they accomplish it totally differently and for different reasons. In managed debugging, your code really does stop normally, but there is a debugger helper thread in the debuggy that provides access to key structures and otherwise relays important information back to the debugger, so technically the debuggy isn't completely stopped. So far so good, but if that were the extent of the situation, then this wouldn't be a very interesting discussion. Maybe you could call that nearly hard mode or something. The real situation is a lot more complicated. One complexity is the fact that if the user tries to stop the debuggy because it has say an infinite loop, it is possible that the debuggy is in the middle of some runtime call and not directly executing the code the user wrote. It could be in the middle of a garbage collection, for instance. If that happens, you don't really want to stop the program right away, do you? If you did, you'd find that your universe looks wrong. Some of the objects have been moved, some have not, some pointers may still need to be corrected. In short, the world is not in a good state, and there are lots of these temporarily bad states that could be visible to a debugger. Ouch. So this is another typical soft mode problem. When you try to stop, you kind of have to skid, get the debuggy somewhere sensible, then stop or pretend to stop. If that wasn't bad enough, the managed debugging has to work in a hybrid program. That is partly managed and partly unmanaged, maybe with some threads having different combinations. So if you try to stop one thread that is unmanaged, you should be able to do the usual hard mode thing, but if you then try to inspect a different thread that is managed well, that could then cause you problems unless you're treating each thread as it needs to be treated for the kind of code it's running at the time it stopped. Oh my. Add to this fun the fact that you often have to actually run managed code to do normal debugger things like evaluate properties, and you find that our poor debugger folks had a few things on their minds while they were integrating all of this. It is so easy to assume those call stacks and parameter values are easy. Let us pick a couple more of the more technically interesting problems from that bulleted list I started with. One very interesting one is the one forms designer. Now this particular designer is interesting, perhaps unique at the time, because it needs to provide a full fidelity visualization of the form you are authoring, including, for instance, controls on that form you have written yourself in the very same project. These are what I like to call the first-party controls. It is easy to show that in general the only way you can provide that kind of fidelity is to actually run the code in the designer. So now we have to take the code you were writing, compile it on the sneak, load it within the IDE itself, using the very same framework of course, and then you can see your whole form, panels and all, just as it will appear in your application. Wrap it with handles and rulers and so forth to allow direct manipulation, and you have yourself one very slick designer. Not easy to get that right. What about all that new IDE integration and extensibility? Well, to make that all happen you have to painstakingly go over all of the extensibility features that are in each of the existing shells, formalize them with clean contracts. Usually after conducting personal interviews to find out what the existing informal contracts really mean, and then fit those into an all-new framework of interfaces and components that is itself extensible by third parties. Naturally this is a totally thankless job, and it is as likely as not that everyone involved will say you did it wrong no matter how careful you are. It is kind of like tax assessment, you know you have it perfectly fair when everyone hates it equally. But in the end it was super successful. There are literally dozens, if not hundreds of language extensions available for Visual Studio. You really could do this even if you didn't work in Redmond. I could keep writing about how technically impressive Visual Studio Net was. Maybe I could even win a debate with the thesis Visual Studio Net was the most technically impressive release ever, but the fact of the matter is a lot of people didn't like it. History isn't all sunshine and roses after all. I think I'd be remiss if I didn't talk about at least some of the sore points, so I am going to hit one squarely on the head. A lot of VB programmers did not want VB.NET at all and like VS.NET just as much. That is, they didn't like it at all. Why? Well, the answer to that question is probably a whole book right there, but let me boldly make some guesses. First, VB.NET was not the language they wanted. The runtime changes presented a challenge. There was WinForms to learn, for instance, but I think those might have been more acceptable if the language itself had been more VB-ish. Traditionally there had always been a compiled version of BASIC and an interpreted version at the same time. VB.NET decidedly had that compiled language feel, and it didn't sit well with those that wanted an interpreted feel. I think a language that was more like Iron Basic, for example, like our Iron Python language, but BASIC instead of Python, still targeting Net, would have been well received. It scripts like a dream. It has direct access to Net objects. You can run it in a little immediate window if you like, and change anything at all about your program on the fly. I suspect we would have loved to deliver such a language, but during that time we simply didn't yet know how to do so. Second, VS.NET was not the IDE they wanted. They were used to something smaller, tailor-made for VB that had genetically evolved for VB users, and this wasn't it. In the initial version of the integrated shell, edit and continue wasn't working for the .NET languages, leading to the astonishing first-time situation that the C system had edit and continue and the RAT programming languages did not. I think the net of all this was that there were divided loyalties among the generation of Versus users.